we're told given g of x is equal to tan of x minus 3 pi over 2 plus 6, find g inverse of x, and they want us to type that in here. And then they also want us to figure out what is the domain of g inverse, the domain of g inverse of x. So I've got my little scratch pad here to try to work that through. So let's figure out what g inverse of x is. This is g of x. So g inverse of x, I'm essentially, let me just read, this is g of x right over here. G of x is equal to tangent of x minus 3 pi over 2 plus 6. So g inverse of x, I essentially can swap I can replace the x with the g inverse of x and replace the g of x with an x. So, and then solve for g inverse of x. So I could write that x is equal to tangent of g inverse of x minus 3 pi over 2 plus 6. So let's just solve for g inverse of x. And I actually encourage you to pause this video and try to work through this out, or work it out on your own. So let's subtract 6 from both sides to at least get rid of this 6 here. And so I'm left with x minus 6 is equal to the tangent of g inverse of x minus 3 pi over 2. Now let's take the inverse tangent of both sides of this equation. So the inverse tangent of the left-hand side is the inverse tangent of x minus 6. And on the right-hand side, the inverse tangent of tangent, if we restrict the domain in the proper way, and we'll talk about that in a little bit, is just going to be what the input into the tangent function is. So if you restrict the domain in the right way, tangent, the inverse tangent of the tangent of something, of say theta, is just going to be equal to theta. Once again, if we restrict the domain, if we restrict what the possible values of theta are in the right way. So let's just assume that we're doing that. And so this is the inverse tangent of the tan of this is going to be just this stuff right over here. It's just going to be that. It's going to be g inverse of x minus 3 pi over 2. And now we're in the home stretch. To solve for g inverse of x, we could just add 3 pi over 2 to both sides. So we get, and actually let me just swap both sides. We get g inverse of x is equal to the inverse tangent of x minus 6. And then we're adding 3 pi over 2 to both sides. So this side is now on that, or this side's now on this side. So plus 3 pi over 2. Plus 3 pi over 2. So let me actually type that in. Let me see if I can remember it, because I'm about to lose this on my screen. So inverse tangent of x minus 6 plus 3 pi over 2. So let me write that down. So let me type this. So g inverse of x is going to be the inverse tangent. So I could write it like this. The inverse tangent of x minus 6, and yes, it interpreted it correctly, inverse tangent. You can view that as arctangent of x minus 6 plus 3 pi over 2. And it did interpret it correctly. But then we have to think about what is the domain of g inverse. What is the domain of g inverse of x? So let's think about this a little bit more. The domain of g inverse of x. So let's just think about what tangent is doing. So the tangent function, if we imagine a unit circle, so that's a unit circle right over there. I guess we can imagine it to be a unit circle. My pen tool is acting up a little bit. It's putting these little gaps in things, but I think we can power through that. So let's just say, for the sake of argument, that that's a unit circle. That's the x-axis and that's the y-axis. If you form an angle theta, if you form some angle theta right over here, the tangent of theta is essentially the slope of this terminal ray of the angle, or I guess you could call it the terminal ray of the angle. The angle's formed by that ray and this ray along the positive x-axis. So the tangent of theta is the slope right over there. And you can get a tangent of any theta except for a few. So you can find the tangent of that. You could find the slope there. You could find the slope there. You could also find the slope there. You could find the slope there. But the place where you can't find the slope is when this ray goes straight up, or this ray goes straight down. Those are the cases where you can't find the slope. There, the slope you could say is approaching positive or negative infinity. So the domain of tangent, so tangent domain, so the domain is essentially all real numbers, all reals, except multiples of pi over, I guess you could say pi over 2 plus multiples of pi, except pi over 2 plus multiples of pi, where k could be any integer. So you could also be subtracting pi, because if you have pi over 2, if you add pi, you go straight down here. You add another pi, you go up there. If you subtract pi, you go down here. Subtract another pi, you go over there. So this is the domain. But given this domain, you can get any real number. So the range here is all reals. Because you can get any slope here. You can increase theta if you want a really high slope, decrease theta if you want a really negative slope right over there. So you can really get to anything. Now, when you're talking about the inverse tangent, by convention, you're going to make tangent invertible so that you don't have multiple elements of your domain all mapping to the same element of the range. Because, for example, this angle right over here has the exact same slope as this angle right over here. And so if you have two thetas mapping to the same tangent, then that's not, if you don't restrict your domain so that you only have one of them, it's not going to be invertible. And so the convention is that to make tangent invertible, you restrict its domain. So you restrict the domain to the interval from negative pi over 2 to pi over 2 in order to construct the inverse tangent. So the inverse tangent, you can input any real number into it. So the inverse tangent's domain, this is just a convention. They could have restricted tangents domains as long as for any theta, there's only one theta in that domain that maps to a specific element of the range. But the convention is, well, inverse tangent the convention is to restrict tangent's domain between negative pi over 2 and pi over 2. So inverse tangent's domain is all reals, but its range is restricted. Its range, and this is by convention, it's going to be between negative pi over 2 and pi over 2 and not including them. So let's go back to our original question right over here. What is the domain of G inverse? So let's look at the domain of G inverse. Well, G inverse, the domain of this, I could put any real number in here. Any real number here. Now, what this is going to pop out is going to be something between negative pi over 2 and pi over 2. But they're not asking us the range of G inverse. That actually would have been a more interesting question. They're asking us what's the domain of G inverse. And I could put in any real number right here for x. So let's put that in here. So the domain of G inverse of x, it's negative infinity to infinity. But actually, just for fun, and let's just verify that we got the question right, and we did. But just for fun, actually, I am curious. Let's just think about what the range of G inverse is. So the range of this thing right over here is going to be between negative pi over 2 to pi over 2. That's for this part right over here. And then we're going to add 3 pi over 2's to it. So the range for the entire function, so the range for this thing, the range is going to be, what the low end, if we add 3 pi over 2 to this is going to give us 2 pi over 2, which is just going to be, so 3 pi over 2 minus pi over 2 is going to be 2 pi over 2, which is just pi, all the way to 3 pi over 2 plus another pi over 2 is going to be 4 pi's over 2, or 2 pi. So the range of G inverse of x is pi to 2 pi, and it's an open interval. It doesn't include the boundaries. But its domain, you could put any value for x here, and it will be defined.